Today we're going to have a look at factorising using the difference of two squares method. Okay, there's a wee thing we need to know because factorising and expanding brackets is like the opposite of each other, it's the undoing. So if we've got expanding brackets, if we were to multiply out a bracket, we would get a factorised result. And similarly, if we were to have an expression and it said to factorise, well that would essentially mean put the brackets back in. Okay, so for example, if I was asked to factorise 6y minus 24, if I was asked to factorise 6y minus 24, the highest common factor is 6, and then inside my bracket I would have y minus 4. And in order to check if that was correct, I could factorise that result. I could multiply out that result and that would become 6y minus 24. So it's quite cyclical. So what we can do is we can kind of think about this here. Let's imagine that we had this as a result. X plus 3, x minus 3. Okay, and I'm just going to do some working over here to work out what that would be. If I wanted to multiply that out, x plus 3, x minus 3, this would become x squared minus 3x plus 3x minus 9, which would give us x squared and minus 9, because that minus 3x and that plus 3x would simplify to 0. So what we could do is over here we could say, okay, that's going to become x squared minus 9. And if we were to follow that kind of approach as we saw above, if we expand these brackets, we would get this. And it follows that if we factorise this, we obtain this. So what we call factorising when we're looking at a type such as the one that I've got circled there, x squared minus 9, is that we refer to that as a difference of squares, a difference of two squares. Okay, we'll just try and maybe look at another couple of examples. Let's imagine we had the result x squared minus 16. Well, straight away, I know that this is going to become x plus 4, x minus 4, using the same sort of idea from above. Okay, there's maybe a connection that you can see that you might not be able to see yet, but we'll have a look at it now in a more formal way and have a look at a few examples. Okay, so when we factorise, there's like a 3-step process that we go through. Step 1, is there a common factor? Step 2, is there a difference of two squares? And step 3 is when we'll look at trinomials. So today we're going to have a look at a difference of two squares. I want us to first write down our general result. See if we are ever asked to factorise the following. If we are ever asked to factorise something squared, take away something squared, our result is going to be x plus that something, x minus that something. Okay, I would maybe ask you to bubble that, highlight it, make it important. Because if we apply this to this example here, I've got something squared take away 16. Well, I know that 16 is the same as 4 squared. So notice here, like a squared is the same as 4 squared here. And then my brackets became x plus 4, x minus 4. So let's have a look at 3 examples. I'm just going to write down factorise the following. remember, to factorise means to put the brackets back in. Okay, so number 1, excuse me for that. Let's imagine we want to factorise x squared subtract 81. The first thing we need to think about is there a common factor? Remember, that's always step 1. So can I take a common factor out of this expression? No, I can't. So step 2, can I write this as something squared to take away something squared? Okay, probably need to just make sure we're aware that when we say something squared, we're referring to our square numbers. So 3 squared is 9, etc. Okay, so 81 is a square number. So what we can do is we can rewrite 81. We can rewrite 81 as 9 squared. And I've now got it into a similar form as up here, because I've now got something squared take away something squared. And because I've got it in that form, we can write that as x plus 9, x minus 9. Or if you wanted x minus 9, x plus 9, it doesn't matter. And remember what we said when we're looking at a common factor, we can do our check at the side to make sure that we get back to what we started with. So if we were to multiply this out, x squared minus 9x plus 9x minus 81. And do you notice that each time, because we've got the differing signs there, the middle terms are just going to simplify to 0. And in this case, I've got x squared minus 81 as required. Okay, so I know I've got that one correct. That was example 1. Let's go y squared minus 49. Let's factorise this. So step 1, is there a common factor? No. Do I have something squared take away something squared? Well, I know that 49 is the same as 7 squared, because 7 times 7 is 49. So I've now got into the form of something squared take away something squared. So I can factorise this into my double brackets as y plus 7 and y minus 7. The only way that I know for a fact that I'm right is if I do this check. You should be able to self-mark your own work if you always do this check. What's that going to be? Y squared minus 7y plus 7y, well that's going to be 0, minus 49. So y squared minus 49. So I know that this is correct. Let's go number 3, let's go 100 minus w squared. Okay, so do I have a common factor? No. Do I have something squared to take away something squared? Well, I know that 100 is 10 squared. Okay, so I've now got something squared take away something squared. The order is important here. Okay, so this is going to become 10 plus w, 10 minus w. Okay, not w plus 10, w minus 10. It's important we have it in this form here. Okay, so if we want to do our check, of 10 plus w, 10 minus w, 10 times 10 is 100, minus 10w plus 10w minus w squared, that's going to be 100 minus w squared. So I know that I'm correct. Okay, so make sure you've got those 3 examples noted down. Those are the most basic forms of factorising with a difference of 2 squares. And these checks here will always confirm if you're correct.